we will see design of normalized Butterworth filter. Actually, in the filter we have IR filter and FIR filters. In first we will see IIR filters. In that IIR filters, we have Butterworth and Chebyshev. Okay, mainly there are four actually. So low pass filter, high pass filter, band pass filter, and stop band filter. Okay, so through those things we can develop a Butterworth and a Chebyshev. So you can observe the difference between Butterworth and Chebyshev. So today we will concentrate on the design of Butterworth filter. Okay, so to design this, what we have to do is to design this one we have again two types. One is analog Butterworth filter, and we have a digital Butterworth filter as well. So now we will see how to design the analog Butterworth filter. Okay, to design this we have a transfer function. Always we have to find we can express our design of filters in the form of transfer functions only. Since it is an analog, so we can write HA of S, which is analog Butterworth filters transfer function, is ohm C raised to n divided by summation of S minus Sk. Here ohm C is the cutoff frequency, which can be calculated by the formula ohm C is equal to ohm P divided by 10 to the power of minus Kp by 10 minus 1 to the power of 1 by 2n. Okay, radian per second. We have to calculate these things by using this formula. And this is our analog filter Butterworth filters transfer function. Okay, and this is ohm C, so which we can calculate this. Next comes summation of S minus Sk. S minus Sk indicates the number of poles. How many poles are going to be involved in this? Like which all the poles we have to consider in this S minus Sk. So for that we have to how many poles? For that we have to find out first order of the filter. Okay, so how to find out the order of the filter is by using the formula n is equal to, okay, we have to derive this equation, since we have seen that one in the previous video. So today we will see how to use this how to use that formula. Okay, n is equal to, it's a ratio of log of 10 to the power of minus Kp by 10 minus 1 divided by, okay, log of 10 to the power of minus Kp by 10 minus 1 divided by 10 to the power of minus Ks by 10 minus 1 to log of ohm P by ohm S. Okay, so by using this we have to first find out the number of order, okay, order of the filter. So see, now what we have to do is ultimately we have to express design in the form of HA of S is equal to analog filter. So HA of S is equal to ohm C raised to n divided by summation of S minus Sk. In that, ohm C can be calculated by using this formula, and n, order of this filter, can be calculated using this one. Once you calculate this order, if this order is even, okay, so if this order is even or it may be odd. Suppose if your order of the filter is even, then we have to use this Sk as number of poles, like how to calculate the poles as 1 at an angle pi by 2n plus k pi by n. Okay, whereas n is odd, okay, when n is odd, for example 3, 5, 7 and so on. So if the order is odd, then Sk will be equal to, poles will be equal to 1 at an angle k pi by n. Okay, where k is 0, 1, 2, 3 up to 2n minus 1, where n is Okay, so this is for even and odd, right? So now k is equal to 0, 1, 2 up to 2n minus 1. So where n is number of the order, how we can, what we have calculated. So that's 2n minus 1 is our k. We'll see one example for this design, like Butterworth low pass filter has to meet the following specifications. First one, passband gain Kp is equal to minus 1 dB at ohm P is equal to 4 radian per second. Second one, they have given the information, stop band attenuation greater than or equal to minus 20 dB. Okay, at ohm S is equal to 8 radian per second. Determine the transfer function HA of S of the lowest order Butterworth filter to meet the above specifications. Okay, this is the question. Now let us take the data whatever they have provided. Okay, so this one is so they have given Kp is minus 1 dB. Okay, minus 1 dB Kp is minus 1 decibel at for ohm P is 4 radian per second. Similarly, Ks is equal to minus 20 decibel. Okay, stop band attenuation is Ks minus 20 decibel. Ohm S at ohm S is 8 radian per second. So now we will find out the order of the filter. This is what the data we have. Kp is equal to minus 1 dB and all. So therefore formula now n is equal to ratio of log of 10 to the power of minus Kp by 10 minus 1 whole divided by 10 to the power minus Ks by 10 minus 1 whole divided by 2 log of ohm P by ohm S. So now let us check, do we have all the parameters or not? Okay, first, so Kp, yes, we have a Kp, and ohm P we have, ohm S we have, and Ks also we have. Now let us substitute all the values of this one. So log of 10 to the power of minus Kp is 1, so minus of minus 1, so which is plus 1 by 10. Okay, 10 to the power of 1 by 10 minus 1 divided by 10 to the power of minus Ks, minus plus, so 20 by 10 minus 1. Okay, whole divided by 2 log of ohm P is 4 and ohm S is 8. So once you do this, we get 4.289. So we can take approximately as 5. Therefore, n is equal to 5. Now, n is 5, it means it is odd. So when n is odd, poles can be calculated. Sk is equal to 1 at an angle k pi by n, where k is 0, 1, 2 up to 2n minus 1. So here so 1 at an angle k pi by 5. Okay, k is equal to, we have to start calculating 0 at 0, 1, 2, 3, 2n minus 1 means it is 2 into 5, 10. 10 minus 1 is 9. Till 9 we have to calculate this number of poles, like poles we have to calculate. All poles whichever we calculate, see, observe, this is 5, n is equal to 5 means we will get only 5 poles. Okay, 5 poles we are going to get. Thing is, all the poles whichever we calculate, 0 to 9 we are going to calculate. So 0 to 9 all these poles may not be stable. So now approximately 10 total 10 poles we are going to calculate. Among those 10, all 10s are not going to be suit for this filter. So then which all poles we have to choose? Let us see. So which poles lies left side of the S plane? Okay, or else we can just remember in this graph which all lies this side, like left side of this plane, which all lies at this side. Those poles indicates the stability of the filter. Okay, intention of having filter is also to check this system stability or not. Okay, so then we have to choose which are the poles lies left side of the pole. We will see how we can choose that. Okay, now let us do it for s is equal to k is equal to 0. So s naught, okay, s naught is equal to 1 at an angle 0, which is equal to 1. 1 belongs left side or right side, we have to choose. So before that we will calculate all this first. So s1 is equal to s naught over, so k is equal to 1 now. S1 is equal to 1 at an angle k. K is 1. 1 at an angle pi by 5. 1 into pi by 5. So which can be calculated using this calci. So please keep your calci in radian and complex mode. So this will be 1 at an angle. Okay, 1 at an angle which is pi by 5. Pi, I'll take in the bracket, pi by 5. Okay, check what you have got, put it in SD form. So this is 0.0809 plus 0.5877 J. Okay, this you have to write. So which is 0.809 plus 0.587 J. Okay, this is one more pole. So now we have to check whether is this pole are going to belong to the left side or a right side. Okay, so before that we'll calculate. S2 is equal to, S2 is 1 at an angle k pi. K is 2 pi by 5. Okay, 2 pi by 5. So we'll calculate that also. So 1 at an angle, take a bracket, it is 2 pi by 5. 2 pi by 5. Let us check what we have got. Press SD, you will get 0.309. Okay, so then plus 0.95. Okay, I'll write this 0.309 plus 0.95 I. Okay, similarly S3 is equal to, if you do so, it is 3 pi by 5. Its answer is minus 309 plus 0.95 I. J you can take. S4 is equal to 1 at an angle 4 pi by 5, which is equal to minus 0.809 plus 0.587 I. S5 is equal to 1 at an angle 5 pi by 5, which is cancel each other. So this is 1 at an angle pi, which is minus 1. So therefore S6 is equal to 1 at an angle 6 pi by 5. Its answer is minus 0.809 minus 0.58J. Okay, 8J. Therefore, and further, S7 is equal to 1 at an angle 7 pi by 5, which is minus 0.309 minus 0.95J. S8, which is equal to 1 at an angle 8 pi by 5, which is again 0.309 minus 0.95J. S9, which is equal to 0.809 minus 0.587J. Okay, now we have to check which all lies left side of the pole. So now when we are checking left side, so what we said is this side it has to come. So DSP and signals, which this subjects once we are learning, we have to remember this graph. Okay, I always prefer this to say this graph. This indicates negative of the x-axis. This indicates positive of the x-axis. Right? This is the magnitude of positive y-axis, and it is like magnitude. It's nothing but y-axis negative. Okay, this is y-axis negative. This is y-axis positive. Okay. So now what we said is poles supposed to lies in the left side of the S-plane. It means this roots, or you can say poles, supposed to be minus. Okay. Let us check one by one. So first one is S0, which is equal to 1 at an angle 0, which is 1. 1 is right side. So this is not our pole. Similarly, second one is also positive. We can express this one in, like, 1 at an angle, this one, like, 0.89. This comes in again right side. Okay, so this is also not a pole. And this pole, in the sense, we should not consider this pole. Among these poles, which poles are negative, or you can say lies left side of the S-plane, that we need to consider. Okay, so this is minus, see, minus 0.309. So this lies left side of the S-plane, and even minus the 0.809, this one and this one also lies in the left side of the S-plane. And which all we calculated, 7 also lies, 8, no, it is positive, this is also positive. Therefore, how many poles we have? So here we have S3, okay, S3, S4, S5, S6 and S7. Therefore, which all the poles? S3, S4, S5, S6, S7 are the poles which we are going to consider. Okay. Therefore, according to the formula, HA of S, which is equal to ohm C divided by summation of S minus SK. So we need to calculate ohm C. Okay, so we will calculate later. So now we will write this ohm C divided by which all those SKs are these. Okay, so S minus S3 into S minus S4 into S minus S5, S minus S6 into S minus S7. How many poles are there? 1, 2, 3, 4, 5. Okay, these we have to consider. So now what we have to do is, let us calculate ohm C, or you can calculate at the last. No, not a problem. Okay, so we will hold this ohm C as it is. Ohm C divided by, we will substitute S minus S3, which is S minus S3 is minus 0.309 plus 0.95 J. Okay, this is S3. Next, S4 is S minus of S4 is minus 0.809 plus 0.587 J. Okay. Next, S minus S5 is minus 1. So minus plus. So S plus 1. Another one is, so next S minus 6. S minus of S6 is minus 0.809 minus 0.58 J. Okay. Next, last one is S minus S7. S7 is minus 0.309 minus 0.95 J. Okay. Just we need to simplify this. If you simplify this, we can write this one as S plus 0.309 minus into plus is minus 0.95 J. Okay. And another one is S plus 0.809 minus 0.587 J. Next, S plus 1. S plus 0.809 minus into minus plus. So plus 0.58 J. Last one is S plus 0.309. Oh, I'm sorry. Okay, just I am multiplying this. S plus 0.309 minus into minus plus 0.95 J. Okay, these are the poles which we have indicated actually. So now in this, what we have to see is simplification. We have to see how we can simplify this is, if you just observe carefully, see this one, this S plus 0.309 minus 0.95 J. We have somewhere here, yes, we have this one also. This and these two are same. So, but check S plus 0.309, S plus 309 minus 0.95 J plus 9.5 J. It means, shall we take this as A minus B and A plus B? It means, can we write this one as A square minus B square form? Okay, in a similar way, this also we can check, which is S plus 809 minus 0.587J. If you check this one with this one, both are almost same. Thing is, this we can consider A and this part we can consider as B. So similarly here A and B. It is A plus B, A minus B, which is again A square minus B square form. So this way we can simplify. Once if you simplify this one, we get this after simplification. Okay, now we can calculate ohm C is what? We have a formula, so directly we can substitute ohm P divided by 10 to the power of minus Kp by 10 minus 1, okay, to the power 1 by 2n. This is the formula. All values we know. If you substitute all these things, we get the answer. Like, ohm P we know already what is the value of ohm P, and Kp also we know. Just substitute the values, we get 4.5787 radian per second. Okay, now in the place of this ohm C, just replace by 4.578 to the power, okay, to the power, sorry, it is formula is to the power n, it is. So to the power n, okay, n is nothing but 5. So now if you simplify this and place, this is our transfer function of Butterworth filter. Okay, and this is analog Butterworth filter. If at all they specify to calculate the digital filter, then what we have to do is, since it is a low pass filter, so if we would like to express in frequency domain, like transformation, then S can be replaced by S by ohm C. Wherever we have S, in that place if you replace this S by ohm C, then that will be in frequency domain. Okay, for example, HA of S, which is equal to, okay, then it will be considered as H of S, which is equal to, same, everything remains same, 4.578 raised to n or 5 divided by, wherever we have S place, we have to just substitute by, replace by S by ohm C. So H by ohm C, already ohm C we know 4.578, we can just replace this. If you get this 4.578 S divided by 4.578 square plus 0.608 into S divided by 4.578 plus 1. Okay, this is 1. Another one is, okay, another one is this, okay, which is S square, that is nothing but S divided by 4.578 square, S square, plus 1.618 into S. S is S divided by 4.578, okay, plus 1. So this is what our frequency domain, same filter. Okay. Now we will solve one more numerical to design the analog Butterworth filter, okay, which is HA of S we call, right? So to design this, as we have followed the steps, saying first we should have a KP and ohm P and KS and ohm S, which is passband gain and passband obviously frequency, and then this is stop band gain and then stop band frequency. So when we have these things, usually they note they'll provide these datas, okay, KP, KS, ohm P, ohm S. So through this we will find out the first n order of the filter, and then based on that n we are going to use the formula HA of S is equal to, so ohm C square, ohm C to the power n divided by, this is divided by, we have summation of S minus SK, where this SK represents number of poles, and number of poles will be dependent on the number of order of the filter, and K is from 0 to 2n minus 1. Okay, so when we have that case is okay. Now this is quite different. So for the given specification, design analog Butterworth filter. Here neither they have given KP nor they have given KS, ohm P and ohm S. So in this case, how to deal with this? So first we require KP. For that, passband gain. So this is about your passband because this is FP. It is FP, and this is FS, means passband frequency and stop band frequency. So this is a delta P, okay, and then this one is our delta S. So by using this delta P, delta S also we can calculate. So Kp is equal to 20 log of delta P is our formula. Kp is equal to 20 log of delta P. Most of the time Kp they will provide. If not, we have to use this formula. 20 log of delta P. When we substitute this, 20 log of 0.8 comes minus 1.938. Okay, this is our Kp. And similarly, we want OMP also. Will wait. Ks is equal to same 20 log of our delta S, which is called, which can be substituted 20 log of 0.2, which gives us minus 13.98. Okay, these two are Kp and Ks. Next, we have to calculate OMP. OMP is nothing but our omega. Okay, so omega is nothing but 2 pi f. So f with respect to passband, so we will take it as 2 pi fp. So since 2 pi is known factor and fp is given here, which is 1000 hertz. So into 1000 hertz, which comes 2000 pi. Similarly, we have ohms is equal to, again this is also omega, is nothing but 2 pi f, only is stop band frequency, which is 2 pi into 5000. They have specified this as 5000 hertz. So which is equal to our 10,000 pi radian per second. This is radian per second and this is also radian per second. Okay. So now, yes, we have got the required data. Okay. Now we have got in what we wanted, all those datas we have received. So now it is easy for us to calculate the order as well as analog filter. Now let us calculate the order. N is equal to, so formula is the ratio of log of 10 to the power of minus Kp divided by 10 minus 1, okay, divided by 10 to the power of Ks divided by OMP, okay, sorry, Ks divided by 10 minus 1, okay, this divided by 2 log of OMP by ohms. This is the formula. Now once we substitute all the values here, it is a ratio of log of 10 to the power of minus Kp is minus plus 1.938 by 10 minus 1, okay, so divided by 10 to the power of Ks. Ks is minus Ks by 10. Minus Ks means minus plus, which is 13.98 divided by 10 minus 1 divided by 2 log of OMP is 2000 pi divided by 10,000 pi is ohms. So substitute this and calculate. You get, so you get n is equal to 2. Okay. When we have n is equal to 2, actually we can go ahead with a formula saying H of S is equal to OMC divided by summation OMC raised to n divided by summation of S minus Sk. Now we have to start substituting K. K is equal to 0, 1 up to 2n minus 1, which is nothing but n is 2. So 4 minus 1, which is nothing but 3. So it is 0, 1, 2 and 3. So among these, only 2 poles will be available, stable. So those 2 poles only we have to consider. How we are going to consider? Poles which lies in the on the left side of the S plane. So is nothing but minus of value negative, which all poles comes to, those poles we can consider here. So you can calculate it, else directly you can remember when n is equal to 2, poles is this one denominator S minus Sk will be, you can directly write that saying HA of S when n is equal to 2, okay, when n is equal to 2, HA of S is equal to ohm C divided by s square plus root 2s plus 1. This you can remember. If you calculate also, we get the same thing, s square plus 2s plus 1. Right? Now we have to calculate ohm C. Ohm C is again a formula, ohm P divided by 10 to the power of minus Kp by 10 minus 1 to the power 1 by 2n. When you substitute all these values, saying ohm P is 2000 pi divided by 10 to the power of minus Kp minus plus, which is 1.938 divided by 10 minus 1 to the power of 1 by 2n. N is 2, so 2 2s are 4. Okay. Once you calculate this ohms in a calculator, you will get 2309.47 pi radian per second. Okay. Therefore, HA of S will be, you can substitute ohm C, which is 2309.47 raised to 2n divided by s square plus root 2s plus 1. This is analog filter.